All right. Doesn't everyone start their talk by typing make? Oops, we're trying to type make. All right, so this talk is useful namespaces. The PEP 20, Zen of Python, line 19, says namespaces are one honking great idea, let's do more of those. To put this in perspective, the Zen of Python was written in 2004. Python 2.3 was current, so a lot of the features I'm going to talk about came after that. A similar quote from someone earlier is, I like namespaces, it's where I keep my stuff. The tick, paraphrased. Actually what he said was, they can't destroy the earth, that's where I keep my stuff. But close enough. So types of namespaces. There's an official definition of what a namespace is. We often think of lexical namespaces, you know, is this in my function, is this in the module? Module and package namespaces, just the physical layout of where something is defined. Classes and objects, is this defined on the object, on the class of the object? And working set, which is a somewhat more amorphous namespace I'll be getting to. So lexical scope. When in a variable, in a function, you ask for len, it first checks in your function to see if there's a variable named len, then it checks the module, and finally it checks the built-in, and it's probably going to find it there. If you've ever used other languages, C or God forbid PHP, then you know that there's also this global namespace, and there can be a lot of pollution. So whenever you're coding, you actually have to think about, is this a name that someone else is going to use? Am I going to step on someone else? Is this still going to be here when I get back? So lexical scopes in Python help you keep that all straight. Modules and packages, they keep separate things separate. It's defined by the physical layout of the files, but it's also kind of a mental way we organize things. And when you're reading someone else's code, right at the top you see the imports. You see what packages they're going to be bringing in. So if you see they import erlib and they import math, you know they're going to be doing something with cosines from documents fetched from the web. Classes and objects. Attribute lookup on objects is actually extremely complicated. We think of it as simple because most of the time stuff just works. But when you ask for ob.foo, it might be in the dictionary of foo, it might be a descriptor that's referencing an attribute of foo, it might be in the class, it might be something defined in a meta class that adds a double under getAttr to the parent of the class. The nice thing about Python is that these all look the same. It's a pretty low cognitive load, which gets us to working sets. So a working set is just whatever you have to think about right now in order to read or write code. Python fits your brain. So Python has all these little features that make it easier to remember what you're working with. Syntactic sugar. So like I said, that PEP quote was from Python 2.3. In more recent versions of Python, we've gotten some extra tools that help us manipulate and think about these things. But there's nothing new in Python that you couldn't do in Python 2.3 when that was written. All the things since then just make doing those things easier. So we have function decorators, went in 2.4. Context managers in 2.5. Class decorators in 2.6. I don't know of anyone who's actually using 3.2 in production yet. I don't even think I know many people who have downloaded it. But there's this very cool thing that's a decorator context manager mashup that ships standard in Python 3.2 standard library. And as for monkey patching, the reason it got a bad rep was because it was very hard before, or at least it was easy to do wrong. So as we get these extra tools and this extra syntactic sugar, I have to admit, I monkey patch code at least once a week. I monkey patch my own code, I monkey patch other people's code, and it is now tolerable. I'd like to break that taboo. So now that people have been using this new syntactic sugar for a while, what people used to carry around in their own private libraries or their company's libraries has gotten absorbed into the standard lib. And that's happened because people now talk about the same things in the same way, using the same syntax, and all this stuff floats up to the top. So if you're running Python 3.2, you can import functools, which is in the standard lib, and there's a least recently used memoization cache for functions. You can tell it to keep the last 100 unique function calls and return those results, the last 10, but you don't have to write your own memoization anymore. You don't have to write your own cache anymore. You just import it from the standard lib. And that's in there because the functionality, syntactic sugar, has been around for a while. Same thing with class decorators. They went in 2.6, but we've only seen some high-quality class decorators bubble to the top into the standard lib since then. Once again, in functools, we have a decorator, a class decorator, called total ordering, which makes any of your number-like classes easier. Context managers went in 2.5. We're still adding new context manager stuff to the context lib. Like I said, in 3.2, there's this brand new thing that just makes everything easier. And that's decorator managers. So, fix-up decorators. This has been since the beginning of decorators. Anytime you decorate a function, you want the return function, the wrapped function, to look a lot like the old one. So you take the old func and the new func, and you copy some of those attributes, the doc, the name, the argument signature. At the bottom we have mydeco, takes hello ma, creates a new func, and then immediately makes the new func look as much like hello ma as possible. This is common enough functionality that you can actually get it in the standard lib. You don't have to write this into your own decorators. It's actually a decorator. So anytime you write a decorator, you use functools wraps, and it just does all these things for you. The total ordering decorator. This one was one of the first kind of killer apps for class decorators that made it into the standard lib. So once again, it's in functools. If you're defining a number-like object or a string-like object, anything that you're going to do comparisons on, and those comparisons are transitive, which they usually are, you only have to define one comparison that can be composited into other comparisons. If A is less than B, you can say B is greater than A. And in the old days, you would type out all those individual functions. So anyone reading the code would actually have to make sure that you did the right thing on each one, even as you would have to make sure you were doing the right thing as you wrote each one. Now that total ordering is in the standard lib, it's both easier for you to write and for other people to read. Because they say, okay, he's importing this from the standard lib, and I see he's defined the one comparison correctly. Therefore, I only have to read these 5 lines, and I know it's good. At the bottom, we have 2 double ints, an int-like class. First, we compare A to B, and less than gets called. Then we compare A equals B, and the total ordering decorator has taken care of that for us. This is pretty much what the standard lib total ordering decorator looks like. There's no reason you couldn't have done this before. Class decorators aren't required to do this, but since that extra syntactic sugar has been around, people are using it more and the stuff is floating into the standard library. The reason that classes don't default to doing this is because, one, it would be a big change, new and an unexpected behavior. And the other one is that not all classes that define one comparison operator actually define all the other ones in the way you would think. So in the infinite wisdom of the IEEE, you can create a float which is not a number, and the float is itself, but the float is not equal to itself. Cleaning up after yourself. So when context decorators went in, there was a frenzy, and lots of things became context managers as well as what they already were. Context managers allow you to think about less, or at least announce up front what you're doing, similar to function decorators and context decorators. So in this case, we have a name temporary file. We're using it as a context manager. Name temporary file is temp write to it, and then you know as soon as that dedent happens, as soon as you leave that block, you don't have to worry about that temporary file anymore. It's cleaned up. It's gone. So you try to write to it again. You see that it's already been cleaned up. Temp name is still valid. This is the name it used to have. But if you went and dropped into the shell and looked into your temporary directory, that file would be gone. So this is what you could do in 2.3 before any of this stuff went in. If you wanted to do a decorator-like thing, you could. It's kind of a decorator turned inside out. So if you want to acquire and release a lock around a function, it's just call with lock func, acquire the lock, call the func, release the func. But this kind of inverts the order of how people read. So you're defining the work you're going to do, and then at the bottom you say call with lock, do work. So the reader's eye have to jump up and down a little bit. This was never in the standard library. This is, in your little local library. So someone else reading it had to know what it was. Now that this stuff is in the standard library, you don't even have to think about it. This is a decorator that does the same thing. Looks very similar to the inner loop of call with lock. The outer thing is a decorator. It takes a func and returns another func. The inner thing is the replacement func that we're going to replace it with. And it's basically call with lock all over again. It does the lock for you and returns it. So at the bottom we have the actual decorator in action. It says this function, any work that happens in here will happen under a lock. And then you get to forget about it and go on to read what the code actually does. So this keeps your working set small. The things you have to remember short. Quote from Ian Bicking. This is from several years ago. While sometimes its use is justified, those cases are few and far between. Speaking of monkey patching. And the reason why monkey patching was frowned on, it's even frowned on in the Ruby community, believe it or not, is because you never know exactly what the side effects are going to be, especially if more than one person is doing it. So this is a simplified example when I monkey patched a parser. The parser in one of its interior functions had a slow original function that just wanted to get the length of the thing it was going to output. But it could possibly, depending on what part of the parser was running, get a whole variety of different things. It could get a message, which was one of its internal types. It could get a float. It could get a string. And I was parsing a big file, and this was getting called millions of times. And I knew I was always giving it strings. So I was paying for tens of millions of calls to is instance, and I really didn't want to. So I cooked up the fast string replacement, which just does length of the message, because I knew I was giving it a string. But the reason why monkey patching gets a bad rap is because you don't know who's using it differently. So if you go and patch it and just leave it there, some other code could blow up. Tomorrow you could import another library that you didn't use to that uses this library, and they patch it differently because they know they're always going to send it a message. So this is why I think monkey patching is now good. You can change the namespace briefly, and you can do it in a very readable way. So I know I always want to use fast string when I'm using this parser library. So I decorate that function or add a with context manager that patches it, runs the short amount of code that I know will only use that monkey patch, and then it undoes it. Monkey patching yourself. So Armin Ronacher just introduced the other day Unicode Nazi, which is a conversion tool he uses in 2 to 3 transitions. You can do a lot of combinations of strings in Unicode in Python 2 that raise a type error in Python 3. So Unicode Nazi just patches the hell out of everything and raises warnings anytime you do something in 2 that isn't legal in 3. By default, it turns on warnings all the time. But it contains a patching decorator so that it can turn it off and on for his own sections of code. So with Unicode Nazi, blockwise, enabled equals true, says for the duration of this indent. All you have to remember is that for the duration of this indent, I'm going to raise warnings. So it patches it, runs your code, and then goes away. So monkey patching. Not having to monkey patch is better. It's not always an option. Push patches upstream when you can, but releases aren't always instant, and you have to get the work done today. So don't feel bad if you monkey patch with the intention of removing it later. It's relatively safe if you do it in that brief part of code you only need it for. I do this even in my own projects because releases aren't instant. Yeah, I can commit, but it won't be rolled out tomorrow. So actually during sprints, I'm going to be moving some of my monkey patches into the standard lib. So I said in 3.2, they have this cool new thing, the decorator manager mashup. To get there, we just have to look at decorators and context managers and how they're defined a little bit. So the identity decorator is just a function that takes a function and returns another function, and that's what you see at the top. It does nothing. But actually, it's a callable that takes a function and returns something function-like. So here we have a pretty useless class that takes a function and then itself defines call, so that when you call it, it calls the original function. Simple context manager, they just define enter and exit. That's everything you have to do to define a context manager. The enter gets called right before it indents into the scope, and the exit gets called right after it leaves the scope. As you can see, before scope, inside scope, after scope. Existing in, I believe, since 2.5, is context lib context manager, which just makes that manager a little bit easier to write. It mimics the old try finally that context managers frequently replace, but it does it with a generator function. So you define one function, do what you want before the yield, and then do the cleanup you want afterwards. It's very handy. So here's our slightly strange decorator and our very basic context manager side by side. And what you'll notice is that they don't really have any special methods in common. And you'll also notice that enter and exit do the same thing or a similar thing to what just plain call does on the decorator. On the decorator, it's before and after, all in the same method. In the context manager, it's before and after, but each in their own method. What that means is that you can actually take a context manager and turn it into a decorator just by putting those enter and exits a little closer. So this is a decorator that takes context managers and returns a decorator made from that context manager. Context class comes in, define the decorator. It's a function that returns something function-like. The function-like thing is the replacement func. It does with context class, which is going to call the enter and the exit. It's going to call the enter, run the func, then call the exit. Gets all returned back. So in function is now before scope, in function after scope, very similar to what we saw before. So you can merge these both into one class. And I believe this is Michael Ford's insight in his mock library. So this is a class and a little helper function that will turn any of those generator functions, the try, yield, finally, into both a decorator and a context manager. So now in Python 3.2, this is in the standard library. So you can define the little try, yield, finally, call a context manager on it, and then use it both as a decorator and a context manager. All right? Questions?
Hi, Jack.
Hey, Larry.
Go back to your slide where you had the function decorator that was doing the locking class. I just didn't quite understand your example. Either I'm confused or it's a terrible piece of code. Right. So in def call with lock, you're creating a lock, and then you're waiting for it, and then you call func, and then you release it. Mm-hmm. And if you call this on two different threads, you create two different locks, which you then immediately acquire, and so it's not actually protecting anything.
Larry points out that if you call this with two different functions, it's not actually locking anything because they each have their own unique lock. And I would point out to Larry that this is an example slide.
Okay, just making sure.
Any other questions?
What is your take on the abuse of namespaces to do stuff like DSLs?
I'm again it.
Like especially like I was thinking of the use of the with statement to generate HTML. I saw one.
I mean, it's clearly horrible. It's less readable than actually writing HTML. And in general, there's enough Python parsing libraries out there that if you want to write a DSL, it's easy to write the parser in Python. So trying to abuse the language will usually lose you time.
I have a question. Do you have a slide with the identity decorator around? I actually don't know if this has changed. This has changed in Python 3, but there used to be a problem with using classes. I'm not sure now that I say it, but there used to be a problem using classes decorators because when you decorate a method, you don't get the underscore get magic that functions have, so they don't actually work like normal methods. Does this happen here?
The question was, will you accidentally create a bound method when you're doing this?
Actually, that the bound method magic doesn't work when you have a class.
So you're decorating what is already an unbound method. So you're decorating a class method, you're getting an unbound method, and then you try to decorate it, and strange things happen.
Just using these kind of decorators inside the class, the way you normally use to decorate a method, but when accessing instance.method, because method is not a function, but it's actually a class instance, you get the same instance, but it's not bound to self.
Oh, okay. So what he's saying is that if you use this to decorate a class's method, because it's a class, it doesn't automatically get the descriptor protocol.
Yeah.
So yes.
Does this still happen in Python 3?
Yes, you would have to add methods to this demo class that supported the descriptor protocol.
Okay.
Hello, I've got a branding issue. Could you go to the Unicode page?
The which one?
This one with the Unicode from Armin.
Unfortunately, I can't go too fast.
Stop, it was it. That word for that code part may, as I understand the American English, Nazi is for somebody who is in a radical way correct. That's not the way that word is understood in Europe, especially in Germany, and that's not the way that word is understood in Israel. So it may be a branding issue to use that word for a Python module.
The question was, Nazi as in grammar Nazi is benign in the US, but not so in Europe.
Yes, they brought us the problem.
Yes. So you can talk to Armin about that. All right, that's all the time we have for questions. Thank you all for coming.